Hi, everyone. Welcome to our next discussion. And here to lead the way will be Mr. Jim Cook. Jim, take it away.
Great, thanks a lot. Good afternoon, everyone. I know we're in the home stretch before the evening. As you mentioned, I'm Jim Cook. I play a number of different roles, but the one that's most relevant to today is that I'm a member of the Potomac Quantum Innovation Center, and I chair the Policy and Ethics and Standards Center that P. Quick stood up a couple of years ago. Today's conversation is going to be about leveraging existing policy framework to accelerate quantum research and use case application. I have two panelists today. To my immediate right is Vida Cooper, Deputy Program Manager for Strategic Initiatives at NASA. Vida is also the Executive Director for DCQNet, and she's also a member of the Potomac Quantum Innovation Center Steering Committee. And joining us today also is Paul Stimers, Executive Director for the Quantum Industry Coalition, and one of my colleagues in the Policy and Ethics Center for quantum as well. So Paul, Vida, thanks for joining us this afternoon. We have a short discussion today, so I'm just going to go ahead and kick it off just with a little bit of context and then jump into some questions, and feel free to engage Paul and Vida along the way. When we met this time last year, QWC2024, Congress was in the final stages of preparing to reauthorize the National Quantum Initiative Act. That legislation still sits waiting to be passed, but much has been done in the past year by government, some of which you've seen in other discussions, other panels over the course of the last day and a half. And they've accomplished this through the existing policy framework and authorities that exist in government today. Vida and Paul will share their insight into the progress that's being made and their perspectives from an agency perspective as well as an industry and legislative perspective. Talk a little bit more about what more can be done, what authorities can be better leveraged, and the priorities government should focus on to accelerate research, development, and application and ensure U.S. leadership in quantum. So that's the goal for today. We ready? Okay, so in lieu of the reauthorization of NQIA, where do you see the bulk of government's focus been in the past year, and what are the policy or statutory authorities that have been driving your efforts? Vida, why don't we start with you from an agency perspective?
Okay, sure. So from a NASA perspective, and even I would share some of the NASA adjacent agencies and departments that we collaborate and partner with. I'm sorry? Thank you. Is that better? All right, great. Thank you. All right, so from a NASA perspective and also what I would call NASA adjacent, just meaning departments and agencies that we partner with, we really are focusing on mission. Okay, so that's probably not the opening that many would expect, but for those that really are the stewards of executing the mission scope for a specific agency, we cannot just tap dance and hype on one specific capability that has come into, popularity. So to further go down that route, what focusing on mission looks like for NASA is that we have a mission and a vision that really is founded on serving all of us here, right? That humanity perspective in terms of understanding our position and our place in the universe. And so with that, there are core science questions that we seek to answer. And then from there are key observables and measurements that we essentially need to execute in the physical world with observatories in space. And so that leads to the requirements that are pertinent for capabilities and functions that have to be on board these systems that we create and that we make. Oftentimes it goes beyond what is just the state of the art. And so in that regard, how we're then really leveraging and taking advantage of quantum is in just the very sober, boring engineering work of doing your trades and your analysis against your requirements and seeing what actually, in an unbiased way, rises to the top. If we can do it classically, we do it with no risk or low risk, right? If we can do it in a way where we are leveraging and exploiting quantum, then we absolutely are all over it. So what history has shown is that going back as far as the 70s, NASA has actually leveraged quantum, in various ways in space and in missions and on test beds that are flying and orbiting right now on the space station. And so that's what mission looks like. There are other agencies that have their versions of this, but we may not go around hyping it. I'll just share from an authorities act, since you asked from a statutes perspective. NASA, of course, was founded with the 1958 National Aeronautics and Space Act. That gives us to the objectives essentially that we pursue. The other piece that we have and we leverage a lot is essentially something called an actual Space Act, and that is something that we leverage to really partner and engage with any number of sectors. In some of the later questions, I'll talk about other tools that we use that, again, are really boring, but I think the innovation comes from executive and program leadership and management imagination and ideation for how do I meet my requirements with the tools that are presently in my tool belt. Because frankly, before quantum ever existed, we've been executing to mission with all forms of technological waves that have preceded quantum. So with that, I'll step back so Paul can interject.
Yeah.
Waiting for this to spin up. There we go. And I can get closer if necessary, but hopefully this is good. Thank you. So delighted you're all here. Thank you. And Levita, great to be here with you and Jim. Totally agree. And the mission-focused aspect of NASA in particular, and the capabilities like the Space Act agreement that it has to do to acquire technology, to acquire anything really, in ways that are rapid and relatively low intensity from a vendor perspective, right? So you don't have to jump through a ton of hoops to deal with NASA in the way that you may with other agencies. That's been tremendously helpful to NASA. That's been tremendously helpful to the wide range of new and innovative companies that work with NASA. And so we're seeing a lot of that also in the Defense Department, another very mission-focused organization that is again trying to meet its needs by whatever technological means are available, and at the same time is seeing and pursuing opportunities to invest in new technologies where that makes sense, subject to the mission. Now the Defense Department is working very hard to overcome a tremendously sclerotic acquisition system, and within the Defense Department, entities like DIU and similar sort of carve-outs have been effective at getting around that. What needs to happen is some much more fundamental reform, but that's outside the scope of this conference. But there's part of what we're hoping to see as the National Quantum Initiative Act gets reauthorized, and really hoping to see as a whole of government effort, is more clarity for agencies about the fact that quantum capabilities exist or are coming into existence across computing and cryptography and networking and sensing, and ways for those agencies to think about those capabilities impacting their mission, and then think about ways to acquire, whether it's quantum computing time or actual computers or helium-3 or you name it. And so part of it is really a process of educating the customer as to what options are available and what could be done with a technology that's just being brought into existence now.
Okay, great, thanks. I want to come back to you in a minute and ask you to put your get your crystal ball out and from a congressional standpoint. So let's go give that some thought. But Levita, let's come back to you, because I have to think, I mean, I know a lot about NASA. I grew up in a NASA family. NASA and quantum in the same sense is kind of like peanut butter and jelly. You guys have got to be excited about this. So what are some of the things that you all have been working on that you can share, especially in lieu of NQIA? And given that there were two new sections in QIA that were really, really more firmly developed around talent and international collaboration, how does that fit into what NASA's been focused on beyond just the science?
Okay. All right. So I'm trying to figure out which piece to emphasize. So I think what I would share is right now, we don't necessarily have a specific mission clamoring to use it because, to use, say, quantum sensing, for example, because we have our scientists really looking at exploiting the full range of capability that we can get out of atomic and optical sensors, for example. So one thing that would be helpful with legislation is that if there were very thoughtful, measured, dare I say, conservative and coordinated legislation or policies that came with the right tools and resources that could help accelerate consideration of those things before what I would call is our actual timeline. But in lieu of that, because again, they're mission focused and they work to stay within their envelope of resources and timeframes that they have, what we're seeing is a lot of focus on partnerships. NASA understands that essentially this is something that really, again, all sectors are engaged in. NASA's tracking what essentially is happening in the computing realm. There's a wonderful example where NASA actually has tried to position itself to be a beta tester for computing innovations as they emerge and partnering as appropriate. On the sensing side, some of the things that we're seeing is that they're looking to leverage what they can from partners and then lead where there might be an exquisite gap that, again, connects to requirements. What we're also seeing as well is the establishment of institutes that will enable NASA to articulate needs, but then also provide grants to any number of entities that might be interested in working on some of those hard problems. And so in the near term, I think actually NASA has a very, again, grounded, very practical, steady approach to, if my mission is here, the capabilities I need are here at this level, I will make scalpel-like investments, right, in these specific capabilities, but I'll keep my finger on the pulse of what else is happening so that we can infuse it or procure it at the right time. And that thus far has helped the agency to work within its, frankly, funding, budget, allocations, and timeframes.
So you would say you have a pretty good balance between investing in the research and development on quantum, but also exploring the potential use cases for quantum, so that you would also be driving demand. You're sending ultimately
what I
sending
think
a demand
right
signal.
now today, I see a good balance in that. What I would also share is, again, the approach that NASA is taking is absolutely not novel, right? Because we start with the question of what is it that we're trying to observe or measure. We spend an inordinate amount of time either studying ourselves that end-to-end use case and scenario. What would this look like, you know, if the photons and the bits and everything else are flying sort of end-to-end? What's all the infrastructure? What's all of the mission hardware that you would need? We get industry and academia involved in some of these studies as needed. We get multiple teams involved. So because we literally study things robustly, I can use other words, but robustly, you know, we have a pretty sound approach on when we are ready to move, what's right for government to do, and then what's right to essentially maybe provide the investment opportunities to help seed the marketplace, as the prior panel that was here talked about the role of government. So I'll step back.
Well, Paul, before I ask you about the legislative question, just from your industry perspective, in addition to the types of things that Vida described for NASA, do you see other agencies doing things, again, within the existing framework that you think are particularly instructive and useful as examples for others to follow?
Yeah, I think again, I think DoD is starting to do some really good work there. I think in some other cases, Department of Energy, there are places where that's happening. There are certainly there are centers that got stood up under the National Quantum Initiative are getting underway. I think that's there's still a question about the level of effort that certain departments are putting into research on quantum technologies versus research with quantum technologies. And we're starting to be able to turn that corner, and I think that's, not to segue into this too quickly, but that's part of what the reauthorization of the National Quantum Initiative Act needs to do is help make that shift a little bit. Not leave excuse me, not leave the fundamental research behind, but augment it.
Okay, so now it's crystal ball time. So what's your hope for getting that eventually reauthorized?
Oh, I didn't know that crystal balls were for hoping. I think that there is a hope that we can get the reauthorization done in this calendar year, in this Congress. That will, so the House Science Committee has reported out its version of the bill, including a rule for NASA. The Senate has started to put together, so on the Senate, it's split into two committees. The Commerce, Science, and Transportation Committee has the National Science Foundation and NIST elements of it, and the Energy and Natural Resources Committee has the Department of Energy element. There has been a bipartisan bill introduced to cover the Department of Energy side, and the Commerce Committee is also working on text for the non-energy side. It's possible this year that will all come together, and that will be pre-conferenced with the House, and that will be passed before the end of the year. I won't go beyond possible at this point.
It's a wish list. It's Christmas.
It's possible. It's possible.
It's possible.
I have things on my wish list that are not possible. This is possible.
All right. Vida, what are some of the other barriers that you're running into before we talk about some things that we would like to see Congress and the next administration do by way of policies and authorities? What are some of the other barriers that you're running into that you had to work through?
So I think there's primarily one barrier, but what I would also say, I'm going to flip the question a little bit and just state that despite the timing of the reauthorization that we all await, we're still seeing a number of successes. We are not stalled, and that I think is a testament to frankly, the ability, again, for some of our executives and our grassroots scientists to be able to think synergistically about, I still have this mission before me to execute this capability that would be enabling, and how can I work within the resources that I have, just like many of us do at our kitchen tables, to make this work. So because of that mindset, we really have minimized some of the technical and time frame barriers. With that being said, it has not gone unnoticed by the grassroots researchers, scientists, and engineers that some of the dedicated funding that they could benefit from, for specific types of research is not there, right? And so there are then additional trades, technical trades that are being done in terms of if I have maybe 3 research priorities, then you have to really look at which one takes precedent, right? With, again, what I have in the purse today. So that's primarily the only barrier that we're seeing because frankly, our researchers are bullish. Our community, frankly, across the federal landscape, they're really bullish about trying to bring about a future that capitalizes on quantum capabilities. And then furthermore, we're lucky to have these other sectors in terms of academia and industry and even international partners that are equally as bullish, where some of them are not necessarily seeing the legislation and the policies and the timeframes that they want, but we get into a room, we get on these virtual calls, and we coordinate. What is it you're trying to do in the next 2 to 3 years? What do you want to do in 5 years? How can we do it with what we have? And we make it work.
Good, good. I think you may have actually answered my next question, because I was going to ask you to get your wish list out and what would you like to see from others, not just in government, but your private sector partners that would help you continue to make advances.
Okay. So I'm not going to name specific technologies, but I'll name some specific things that I think are out there for various sectors to take advantage of. So noting, just for the record, who does NASA partner with? And other federal entities partners with these folks too, right? So from an industry perspective, we're looking both for large and small companies. Of course, we partner with other federal agencies, if any of you are in the room, looking at various research institutions, also plenty of colleges, universities, consortia, nonprofits, even some professional organizations and associations. Yes, there are unique opportunities for you as well. And so some of the things that I just want to call attention to for folks that are looking to work with NASA and to see how language in some of these calls are evolving to define needs in quantum would be like engaging, if you're an international entity, engaging with our Office for International and Interagency Relations, known as OIIR. Actually engaging with our offices for procurement, if you want to make sure that your company is set up to be able to be a vendor for the government when you see different calls come out. In addition to that, we have our SBIR and STTR program. There are various research opportunities, again, where grants of all kinds for undergraduate and graduate and postdoctoral opportunities exist, again, where we usually have a section outlined for quantum capabilities that are sought. In addition to that, NASA has sought to leverage things like crowdsourcing and challenges of late that are really open for anyone to be able to respond to. And so there are multiple threads, at times a dizzying amount of threads, where NASA will say, we need help. The other thing is that if there's a field center in your area, even, or if there isn't, you can feel free to reach out to those NASA centers and offices and projects to ask some of the questions about where are you going? What are your pain points? Because whenever we experience a pain point as a federal entity, whenever we experience those challenges, those actually turn into the seed corn when we share those stories, right? Those war stories of, gosh, we wanted to do this, but we got stopped here, right? Because of this challenge. That becomes the seed corn of maybe the next, business plan for an innovator, or that then becomes a requirement for something that we go out and procure. And so what I would just say is stay connected, digest the resources that are put out there for NASA and other federal entities, and I think opportunities abound.
Great, thank you. Paul, from the industry perspective, what would you like to see more from the agencies?
Well, I think again, being a good customer is important, and part of that is knowing how to be a customer, understanding your market. We've argued for the National Quantum Coordination Office talking with agencies about how quantum can help meet their mission, and sitting down with them and really working through. Okay, if you're the Forest Service, can quantum be helpful, or what would the timeline be on which it would be, and then how can you go buy quantum capabilities to meet that mission? Always with a mission focus. This isn't public charity. Excuse me, but really that mission-driven customer capability. Not only does that help meet the mission, but that also sends the demand signal that I think we've heard a lot about this Congress, that then unlocks further funding on the private side that leverages that public funding.
Thank you. So we have a few minutes left, enough time for maybe a couple of questions from anybody in the audience. Yes, ma'am.
on the power requirement. Is it on? Okay.
There you go.
My focus is on the power requirement for data centers, AI, quantum computing. Is that end being properly addressed, considering the growing demand and the need to actually increase output within the next 3 years by about 30, maybe 50% in order to operate all the advanced developments?
That's not really my area of expertise, so.
Certainly, power is a very important aspect of spacecraft management. But there is legislation under consideration in Congress to help bring quantum computing to bear on electric grid management, and that's an interesting aspect. But with respect to your specific question, one of the big challenges for scaling quantum computing is power management and understanding, can we bring to bear the amount of power that however many dilution refrigerators will take, for example, or do we need to find other architectures? That's certainly something that the Department of Energy can be helpful with. That's something that other federal agencies can be helpful with. But that's also a private sector challenge, right? If you're a quantum computing company, you need to be able to tell a story about how you will scale that accounts for your energy needs, right? And if your plan is, I just need the Tennessee Valley Authority to supply my power for my quantum computer, that's not a compelling story, right? So that's partly something that the private sector needs to go ahead and solve with help, certainly, but it's a private sector problem as much as anything else.
It also involves the reliability.
Sure. Yep.
So we good on time? Can we do one more?
One more question?
One more question if there is one. Okay, well, we'll keep
One. Way in the back.
way in the back. Oh, that was, okay, I said it wasn't. Okay, well, we'll keep everybody on time. I know you have a couple more things you probably want to get to. I want to thank Vida and Paul for joining us today, and all of you for attending. Thank you all.
Thanks.
Enjoy the rest of the conference.